Okay, so on the word problem here, this one, I think you guys did pretty good, and then it was this one. Okay, you can tell it's a growth. Why is it a growth? The base is what?
More than one.
More than one. The base of the power is more than one. Identify the hourly percent increase or decrease. Well, what was the percent increase or decrease by? 99%. Now remember, because you had to think of this as 100 times 1 plus 0.99 to the t. So what percent would that be? 99%. Okay. Now, where you guys ran into trouble, some of you, I had some questions, it was on C. And it says, estimate when the bacteria will be 1 million. Well, be careful. This equation was given to me in thousands. So you had to divide by 1,000. And what do you get? Well, you take off 3 zeros and you get 1,000. So basically you want to know when this equals 1,000. So what I did is I went in y1 and let it be this equation, but I had to use x. And then I went into y2 and let it be 1,000. And most of you knew how to do that, but you didn't see your graph. So you had to think about these graphs. That's why I always like to make you guys graph by hand and think about these graphs. y1, where is it starting at? What's my starting value in y1? 100. And is it going up or down from 100? It's going up, right? It's an exponential growth. So that one is going to kind of look like that. Y2 is just a horizontal line at what? 1,000. So if you use negative 10, 10 by scale of 1, you're never going to see it. If you use negative 50 to 50 by scale, you're never going to see it. So what you had to do is make that Y max like 1,200 or 1,500, something bigger than 1,000, so you could see both of those curves. Okay? Does anybody need any more explanation on number 5? That's a good problem. Any other questions at all on the homework? Remember, we use this formula or this formula if you're just told you have annual growth. Okay, percentage of population increases this much per year or decreases this much per year. You use that formula. You use the big formula when you see the word compounded. Oh, I think let me use the right letters. You guys used A equals P times 1 plus R over N to the NT power. That's when you use that one. When you see the word compounded. Just make sure when you raise this power, if you don't use the number multiplied, if you're using both numbers, you have to have parentheses around it. If you have an old school calculator. How'd you guys do? Any questions? Okay, so a heads up on tomorrow. Tomorrow when you guys come in, we're going to go over this homework, and then I have a activity for you to do, and then we will not have homework.
Cool. One pager again?
No. You made me think about what you were asking me, though. Pass the blue papers in. Thank you, sir. Such a difference between honors and regular. You guys all get my papers all turned the right way. Man, they're flipped, turned inside out, upside down, all different ways when I get them out of one. All right. We are going to talk today about the natural base E. The natural base E. And we have all kinds of special numbers in mathematics, okay? In mathematics, we have discovered pi. What's pi approximately? 3.14. Okay, yep. Does anybody remember what pi is? Yeah, it's close. The ratio of the circumference of a circle to its diameter. Diameter, okay? So, but anyway, so any circle you could take and divide those two and you get 3.14. What's I? I taught you to this year. What's I? Square root of negative 1. Square root of negative 1. Well, we're going to add yet another special number. called E, and E is the natural base. Okay, it's called the natural base. So what is E? Well, E is basically what this graph approaches. So for example, if I come to y equals and I put this expression in my calculator. So I put, and you guys can just watch, you don't have to do this. 1 plus 1 over x raised to the x power. If I put this in my graphing calculator and I do a zoom 6, you can see these two pieces of the graph. Now, we mostly talk about as we approach positive infinity, but it does work in both directions. So as I go out towards positive infinity, so as I look at my table, and I'll talk about those two numbers and say error in a minute. As I go out towards positive infinity, now it's 2.25, 2.37, 2.44, 2.48, 2.52, 2.54, 2.56, 2.58, 2.59, okay, and you keep going. It is approaching the number 2.718, 28182846. It's an irrational number, just like pi. Okay, it approaches that number. Now, if I said in a minute, give me a minute, I'll come back and talk about why these two say error. Let's go back for a minute. Why do these two stop? Okay, why is -1 and 0 error? Let's think about that once. Why is -1 and 0 error for x? Anybody know? Josh.
You can't divide by 0.
Okay, so he says if I plug in 0, that's 1 plus 1 over 0 to the 0. Can we divide by 0? Error. How about -1? That was a little bit harder. Think about -1. If I put in -1, okay, what's 1 over -1? And what's 1 plus -1? And anything to the negative power, what do? Put it in the what? Denominator and make this. Can you do that? No. So that's why it's undefined at -1. That one's a little trickier to see. But you can see it on your graphing calculator that it is undefined at 0 and at -1. But that's just a little side note to the graph. All right. So as you can see, we have E equals 2.71828, etc. There are two places on your calculator that E exists. Okay, two places. One of them is above the division symbol. Do you see the division symbol? And see it up in, mine's in blue.
Yeah.
So if I hit second and then hit the divide button, I got E. There's E. Okay. The other place that it is above the LN button on the left side. The only difference is that E prompts me to say, what power do you want me to raise E to? Well, if I want just E, E is to what power? The first. So E to the first is that. So in either case, I get the same answer. I can use just regular E, or I can use E to the first. Okay? So kids will always ask me, well, which one do you want me to use? It doesn't matter. Okay? If you're raising it to a power, I'd probably use the one on the left. If I just need E, I'd probably use the one on the right. They're the exact same thing. It's just that the one on the left gives you a raise to the, it prompts you for that power. Okay? They're exactly the same. Everybody good so far? All right. First one's here. Simplify each expression. All right. Well, guys, this is no different than if you had x to the third times x to the sixth. If I gave you x to the third and x to the sixth, what would you do? Add the what? Okay, so what's e to the third times e to the sixth? None. Okay, it's no different than any other variable. Treat it just like any other variable. This is not algebra 1. Okay, let's look at B. You guys have 16e to the what? 5th over 4e to the 4th. Okay, what do we do with the 16 and the 4? Divide. So 16 and 4 are numbers that we divide just like any other day. What is 16 divided by 4? 4. And then what do you do with the variables? If you have e to the 5th divided by e to the 4th, what do? Subtract. And that's e to the first. So I can just put 4e. So it says simplify. Now, guys, there's a difference between the word simplify and evaluate. Simplify means exactly what we're doing. Evaluate means type in your calculator 4e and give me the decimal value. Okay, so evaluate, give me the decimal. Simplify, just simplify it. Okay, all right, let's go to this one. All right, what are we going to do with that 2 on the outside, Natalie? Distribute it, give it to both. So when you give it to the 3, you get what? 9. And when you give it here, what are you going to get? E to the, what's your sign? Negative 8. X. Okay, very good. Are we allowed to leave negative powers on our paper? So where's the E going to go?
Under the 9.
Under that. 9 is happy. E is not. It becomes E to the
8x.
questions. Okay. Now, what did we do when we had this? Think about this for a minute. We can split it up. Square root of 4, square root of e to the 2x. So we can think of it like that for a minute. Square root of 4, numbers are easy. What's square root of 4, everybody? 2. Now, how can I think about this? This is e to the 2x as an exponent raised to what power? How do we write square root as a power, as a 1/2, right? Do you guys remember that's e to the 2x raised to the? Now, power of a power, what do you do with the 2x and the 1/2? Multiply. What's 2x times a half? X. So my answer is just 2 e to the what? So this is kind of our power rules from last chapter. The only difference is my variables are always going to be e. But the rules are still the same. They have not changed. All right. Are you guys good with the first part? Simplify. All right. Well, if we were to graph these, are these exponential functions? Yeah, because remember, if you have y equals e to the x, e isn't really a variable, right? E is a constant. It's 2 point whatever. All right, so e is a number and then raised to the x power. So this is an exponential function. Sometimes it will be an exponential growth. Sometimes it will be an exponential decay. So when is it what? Well, let's look here. So we have the function in the form y equals a e to the rx is called a natural base exponential function because the base of my power is the natural base, okay? When a is greater than 0, just means when a is positive and r is greater than 0, when your exponent is positive, it's a growth. When a is positive and r is less than 0, when your exponent's negative, it's a decay. All right, so notice here, this represents a growth because my exponent is positive. This one represents a decay because my exponent is negative. All right? Determine whether each represents a growth or decay, then graph the function. What do you guys think? Growth or decay? Why? Because the power is positive. Okay, and now I'm going to make a table of values. And what have we been using? -2, -1, 0, 1, 2. Now, I need to raise e. So I'm going to choose to use the E on the left side of my calculator. I'm going to do 3, and then I'm going to use the E on the left side of my calculator. I didn't hit second. Sorry, 3. I thought I did second. Natural log. Okay. And now it tells me what power do you want to raise it to? I want to raise it to the what? -2. And I got point. Let's go to 2 decimal places. What do you guys get? 0.06?
06. Wait, 0.406. Oh, just one. Round.
Like, what is your calculator showing you? All right. Now, you can do second entry and just change that to a 1. And what do you guys get? 1 point what? 10. Guys, let's think about this for a minute. What's e to the 0? What's anything to the 0 power? What's 1 times 3? Check it if you want. If you don't believe me. Okay, now the next one. I'm going to do 3 e to the first. I got 8.15. And then 3e to the second. 22.1 what? AJ? 7. 22.17. So let's go ahead and graph these. So at -2, I'm not even to 1/2. At -1, I'm just a little above a 1. At 0, I'm at 3. At 2, I'm above 8. And man, 4 or 2 is way up there. Now remember, there's an asymptote on that. So it goes like that. Thoughts? Did it show a growth? Okay. Next one. Sorry. All right, next one. Growth or decay? Why? Because this is raised to a what? A negative. If it's raised to a negative, then it's a decay. Now we're going to make a table of values. -2, -1, 0, 1, and 2. So on this one, I have old school calculator, so I'm going to do, E, and I'm going to do -0.5 times -2, close my parentheses. What'd you guys get for -2? Did you get 2 point what? 72. Finish the table. What'd you guys get for -1? 1.65. How about 0? How about 1? How about 2? I got 7. Did you guys get 7? AJ's having rounding issues today. So at -2, we're up not quite to 3. At -1, we're up like 1.65, then 1, then 0.6, then 0.3. So this one's a little flatter, but is it still a decay? Does it cross that axis? Nope. All right. Questions on that one? We're almost done. This last example is easy. Easy. All right. So somebody came in and said the last couple of problems on the homework lesson, that was just like the book work. Those were just like number crunching in your calculator. I said it was. Okay, that big formula, A equals P times 1 plus R over N to the NT power. When do we use that formula? When you're told that you are using compound interest, compounded monthly, compounded quarterly, compounded daily. That's compound interest. Okay, so you see that up there. Okay, we also have another type of interest called continuous interest, where it's literally compounded instantaneously all the time. And that formula uses our natural base E. That formula is A equals PE to the RT. I always say PERT. There used to be a shampoo, is in a green bottle. I don't know if you guys have ever heard of it. It's called PERT shampoo. PERT, okay? PE to the RT. P is still the amount you what? Invest. E is a constant. It's your 2.7 what? Ever. R is your interest rate is a decimal. T is your time. You and a friend have accounts that earn annual interest compounded continuously. The balance in dollars in your account can be modeled by this formula. So I'm going to come over here and I'm going to say your account can be modeled by A equals 4,500 E to the 0.04T. By the way, how much did you invest in your account? 4,500. What's your interest rate? 4%. Very good. Just out of curiosity. Okay. The graph shows your friend. So this is your friend. Which has the greater principal? Okay, well, I guess I already asked that question. Okay. Your principal is what? You already told me, Drew, you said what? 4,500. What's the principal of your friend? Okay, it's right here. They told you 4,000. It's 4,000. So it says, which has the greater principal? Who has the greater amount, the greater principal? Okay, you have a greater principal. Now, the next part says, which account has the greater principal or greater balance after 10 years? Sorry, which one has a greater balance after 10 years? Well, let's find how much do you have in 10 years. How do we figure that out? Plug in 10 for T. Now, if you're old school, got to have parentheses around that because mine doesn't have math type. So I'm going to come to my calculator. I'm going to do 4,500. Now again, since I'm raising it to a power, I'm going to use the E on the left. 0.04 times 10. And then I'm going to close my parentheses. So how much does yours have in 10 years? What'd you guys get? $6,700. $6,713 and what? 21 cents. Okay. How much does your friend have in 10 years? Well, we're going to have to do a guesstimate for your friend, right? So let's go to 10 years. 10 years would be here. Go up and go over. So about how much do they have? 7,200, 7,100. I'm not sure it's quite up to 7,500 be in the middle. It's not quite that high. 7,200, 7,100. So that's approximately. So who has more? Your friend, okay? Your friend has more. What's that tell you? Their interest rate is better. They have a higher interest rate. Very good. Okay. Homework. Yeah. Natalie, I'm sorry. You're the only stick I called today. Lucky you, huh? So I got Lucas and Julia.